Welcome you all. Now let us see hydrocarbons. Alkanes. Alkanes are compounds that consist entirely of atoms of carbon and hydrogen bonded to one another by carbon-carbon and carbon-hydrogen single bonds. The formula of alkane is CnH2n plus 2. It is subdivided into three groups, that is chain alkanes, cycloalkanes and the branched alkanes. The simplest alkane is methane and it have the molecular formula CH4, and the next one is ethane that have the molecular formula CH3 or C2H6, and then propane have molecular formula C3H8. The physical properties of alkanes, first one is solubility. Due to very little difference of electronegativity between carbon and hydrogen and covalent nature of carbon-carbon bond or carbon-hydrogen bond, alkanes are generally nonpolar molecules. As we generally observe, polar molecules are soluble in polar solvents, whereas nonpolar molecules are soluble in nonpolar solvents. Hence, alkanes are hydrophobic in nature, that is, alkanes are insoluble in water. The boiling point of alkanes, as the intermolecular van der Waals forces increase with the increase of the molecular size or the surface area of the molecule. The boiling point of alkanes increases with increasing molecular weight. The straight chain alkanes are observed to have a higher boiling point in comparison to their structural isomers. The melting point of alkanes, this is attributed to the fact that higher alkanes are solids and it's difficult to overcome intermolecular forces of attraction between them. It is generally observed that even-numbered alkanes have higher trend in melting point in comparison to odd-numbered alkanes, as the even-numbered alkanes pack well in the solid phase, forming a well-organized structure which is difficult to break. The application of alkanes depend on the number of carbon atoms. The first four alkanes are used mainly for heating and cooking purposes and in some countries for electricity generation. Methane and ethane are the main components of natural gas. They are normally stored as gases under pressure. Propane and butane are gases at atmospheric pressure that can be liquefied at fairly low pressures and are commonly known as liquefied petroleum gas. And then higher alkanes are volatile liquids. Uses: alkanes are important raw materials of the chemical industry and the principal constituent of gasoline and lubricating oils. Natural gas mainly contains methane and ethane and is used for heating and cooking purposes and for power utilizers. The first one is methane. Methane is the colorless, odorless gas that occurs abundantly in nature and as a product of certain human activities. Methane is the simplest member of the paraffin series of hydrocarbons and is among the most potent of the greenhouse gases. Its chemical formula is CH4. The structure of methane is it has only carbon-hydrogen and carbon-carbon single bonds. The former result from the overlap of an sp3 orbital of carbon with the 1s orbital of a hydrogen. The latter by the overlap of two sp3 orbitals on adjacent carbon atoms. The bond length amount to 1.09 into 10 power minus 10 m for a carbon-hydrogen bond and 1.54 into 10 power minus 10 meter for a carbon-carbon bond. The bond angle is 1.9 degree 47 degree. The preparation of methane. First one, the catalytic reduction of methyl iodide. Methyl iodide can be reduced to produce methane. The second one is the hydrolysis of aluminum hydride. Aluminum carbide Aluminum carbide can be hydrolyzed to form methane molecule. Properties and uses of methane. Methane is lighter than air, having a specific gravity of 0.554. It is only slightly soluble in water. It burns readily in air, forming carbon dioxide and water vapor. The flame is pale, slightly luminous and very hot. The boiling point of methane is minus 162 degrees Celsius and the melting point is minus 182.5 degrees Celsius. Methane in general is very stable, but mixtures of methane and air with the methane content between 5 and 14% by volume are explosive. Explosions of such mixtures have been frequent in coal mines and collieries and have been cause of many mine disasters. Methane is an important source of hydrogen and some organic chemicals. Methane reacts with steam at high temperatures to yield carbon monoxide and hydrogen. The latter is used in the manufacture of ammonia for fertilizers and explosives. Other valuable chemicals derived from methane include methanol, chloroform, carbon tetrachloride, and nitromethane. The second hydrocarbon is alkenes. Alkenes are defined as either branched or unbranched hydrocarbons that possess at least one carbon-carbon double bond and have the general formula CnH2n. Alkene is often used as synonym of olefin, that is, any hydrocarbon containing one or more double bonds. The general properties of alkene is the members containing 2 or 4 carbon atoms are gases, 5 to 17 are liquids, 18 onward solids at room temperature, and they burn in air with a luminous smoky flame. Density of alkenes are lighter than water, and the solubility of alkenes are insoluble in water and soluble in organic solvents such as benzene. The boiling point of alkenes show a gradual increase with an increase in the molecular mass or chain length. This indicates that the intermolecular attraction becomes stronger with the increase in the size of the molecule. The reaction of alkenes are relatively stable compounds but are more reactive than alkanes. First one, addition reaction. Alkenes react in many addition reactions which occur by opening up by the double bond. Most of these addition reactions follow the mechanism of electrophilic addition reaction. Examples are hydrohalogenation, halogenation, halohydrin formation, etc. Hydrogenation of alkenes produces the corresponding alkanes. Hydration, the addition of water across the double bond of alkenes to yield alcohols. And then halogenation reaction, addition alkenes to produce dihaloalkanes. And then hydrohalogenation reaction, alkenes to form haloalkanes. And then halohydrin formation, alkenes react with water and halogens to form halohydrins by an addition reaction. Oxidation of alkenes to form epoxides. The simplest alkene is ethylene. Ethylene is an important industrial organic chemical. Ethylene is a small hydrocarbon, the colorless flammable gas which is denoted by a formula C2H4 or CH2 double bond CH2. It have one single bond and one sigma bond and a one pi bond. Ethylene is abundantly used in the chemical industry and the polyethylene is extremely produced using ethylene. Further, ethylene is also used in agricultural practices to ripen fruits, germination of the seed, etc. In ethylene molecules, carbons are sp2 hybridized, so it is trigonal planar structure and the bond angle is 120 degree. Ethylene is used as a polyethylene preparation used to make food packaging, bottles, bags and other plastics based goods. Ethylene oxide and ethylene glycol, which is used to become polyester for textiles as well as antifreeze for airplane engines and wings. It is a plant hormone and it is used as hasten fruit ripening in tomato and apple and degreening of citrus fruits. The next hydrocarbon is alkanes. Alkanes is a molecules that contain a triple bond between two carbon atoms. The triple bond is made up of one sigma bond and two pi bonds. The alkanes have the general formula CnH2n-2. It is hydrophobic in nature. The carbon is sp hybridized state. The alkanes are non-polar and it is unsaturated hydrocarbons with physical properties are similar to alkanes and alkenes. Alkynes dissolved in organic solvents have slight solubility in polar solvents and are insoluble in water. Compared to alkanes and alkenes, alkynes have slightly higher boiling points. The uses of alkynes are: the most common use of ethane is for making organic compounds like ethanol, ethanoic acid, acrylic acid, etc. It is also used for making polymers and its beginning materials. Ethane is used for preparing many organic solvents. Alkanes are also commonly used to artificially ripe fruits. The simplest example is acetylene. Acetylene is the chemical compound with the formula C2H2. It is a hydrocarbon and the simplest alkyne. The colorless gas, which is widely used as a fuel and a chemical building block. It is unstable and its pure form and thus is usually handled as a solution. The preparation of alkynes can be prepared by the hydrolysis of calcium carbide. The calcium carbide produces calcium hydroxide and acetylene as the final product. The uses of alkyne burns with a very hot flame. One of its most notable applications is in oxyacetylene gas welding and oxyacetylene gas cutting. Ethane is in the production of portable lighting. For use in mining activities, calcium carbide is often employed in combination with water to generate acetylene, which is used in lamps. Acetylene is also used in the production of several polythene plastics. Thank you.